రికార్డ్ కాదు అట్లయితే. Now shall I start or somebody joining? Okay, okay. I will wait for some time. Vikas Reddy came and left. Okay. Now I will start. For here, last class we saw path sensitization method. Today we will see Boolean difference method. Okay, this is one of the test generation technique. Okay, last class path sensitization method is one of the technique to generate the test vectors. Okay, this is also one of the method to generate the test vectors for the detection of fault. Okay, this is a algebraic method to generate all possible test vectors. Simple in concept but difficult to automate. Okay, this Boolean difference of a function f having the variables, okay, n variables here with respect to one of its variable xi. Here xi is, okay, here 1 to n number of variables, and this Boolean difference method is, and it is noted by the derivative, that is df by dxi. Here function, here what we have to notice is, okay, function f of x1 and xi minus 1, 0, xi plus 1 up to xn, and exclusive or with f of x1 same up to xn here. And what we are doing is, and first we will apply 0 for the first function, and again we will apply 1 for the your second function. Okay, your first function we will take 0, and second we will take 1 for the each uh, possible, okay, your variable. Means your xi is, okay, your xi, it may be, okay, 1 to n, the derivative function. Here xi indicate the 1 to n, and df by dxi, xi indicate the line of the circuit. Okay, here xi indicate the line number of the circuit. Means that is n number of variables, and here derivative df by dxi indicate the exclusive or of the function 0 and 1. Means we can indicate here fi of 0 exclusive or with fi of 1. Means okay, one time we will take function, we will use 0, and second time we will use 1, and we will take exclusive or, okay, Boolean function of once we will take 0 and second time we will take 1, and we will apply exclusive or. Okay, that's why we are calling it as a Boolean difference method or Boolean derivative method. Here if you see the Boolean difference, df by dxi specifies the condition under which any change in line xi will propagate to the output. Means same, okay, like in the last class path sensitization method. Okay, we will starting You will detect the fault. We will detect the fault and we will excite the fault and we will propagate the fault. Okay, here the Boolean difference dfi dxi specifies the condition under which any change in line xi will propagate to the output. Necessary and sufficient conditions to detect a fault xi at okay at c. C is the logic values. Okay, here xi indicate the it may be stuck at 0 or stuck at 1. Okay, at line C. Okay, here yesterday what we have done is same like here also. Okay, first we will excite the fault and we need to propagate the fault. Okay, last class. Okay, we will did on the netlist means logic gates and interconnections, but we will here in this method we will do Boolean expressions or Boolean functions. Okay, here after excitation, a reverse logic value C bar must be applied to Xi to excite the fault. Okay, for excitation of fault, we will apply reverse logic value. C bar must be applied to Xi to excite the fault. Line Xi will have different values in fault free and faulty conditions. Fault free means okay, no fault. Faulty conditions will have different. Suppose we have here AND gate. Okay, suppose here xi stuck at 0. Here in one of the input. Okay, xi is stuck at 0. Then we will apply reverse logic value. Means this line is stuck at 0. So we will apply logic 1. Logic 1. Then we can detect the fault. Suppose if we don't apply logic 1, then your input is 0. Here also some other value 0. You will get 0. You will get 0. Means we cannot detect the fault when we do not take the reverse logic value. Okay. And this change in the line means applying reverse value. The change in line, this xi must be propagated to the outputs. The conditions specified by the Boolean difference or Boolean derivative is df by dxi. Okay. Here the set of test vectors that can detect the fault xi stuck at 0 is given by okay the derivation formula. Okay, this is derivative formula. Here two formulas are there. Okay, here line xi is stuck at 0. Okay, the formula is xi into df of x by dxi equal to 1. And suppose line xi is stuck at 1, then we will use this formula, okay, to detect the test vectors. Whenever 0 is there at fault, means stuck at fault is 0, then we will use xi, means we will apply the reverse logic value for the excitation. So here 0 is there, so we will apply here xi. Here stuck at 1. Here stuck at 1. So here we will apply reverse logic value, means xi bar, xi bar. So these two formulas we will apply for the detection of the test vectors. So here first, when our xi is at stuck at 0, xi into df of x by dxi equal to 1. And next, the set of test vectors that can detect the fault xi at stuck at 1 is given by xi dash, means xi bar into df of x by dxi equal to 1. Here input line xi or xi bar, excite the fault, exciting the fault and propagating that fault to the output. Means here we will use derivative df of x by dxi. Means here line is with respect to xi, x suffix xi. So df of x by dxi. Now we will see one example. We see one example. Okay, we have a 5 logic gates. Okay, 4 inputs A, B, C, D and output F function. Okay, and we say that generate test for C. Means here line C is stuck at fault. Okay, 0 and 1. Okay, here function f equal to, by using Boolean laws we can write f equal to a plus b, a plus b into c bar plus cd here. Okay, starting here function using Boolean laws. Okay, from the logic gates f equal to a plus b into c bar plus cd. Okay, here if we apply the starting derivative, means we'll apply f xi of 0 exclusive or with f xi of 1. This formula if we apply here, f xi of 0 exclusive or with f xi of 1, means here starting this equation, if we apply here c 0, okay, here this 0, if you apply starting this 0, means you will get c0, means this term is eliminated and c bar is 1, so a plus b here, a plus b. Next, whenever xi is 1, c bar is 0, so this term is eliminated, only we have c is 1, so we have only d. Are you understanding? Okay, then we have the function df by dc using the that initial is 0 and 1 exclusive or. Okay, we will get this formula. Okay, this equation. Then when we expand this line, okay, using exclusive or, means a xr b formula, we will write a b bar plus a bar b. Okay, using xr formula we will write a b bar plus a bar b. Okay, like that we will get the this expression. If you apply that rule here xr function, so you will get a d bar plus b d bar plus a bar b bar d. Okay, this equation. Now we will apply for C stuck at 0 and C stuck at 1. For C stuck at 0, 0 means we will reverse value. So you will use, okay, you will use just C. Here stuck at 0. Okay, stuck at 0. So you will use C. C into df by dc equal to 1. Okay, this formula. Okay, if you apply C into df by dc, df by dc is, okay, this one. Df by dc is this one. Okay, into C. Okay, if we multiply that with C, we will get here. If you multiply this one with C, we will get AC d bar, BC d bar plus A bar, B bar, CD. Okay, equal to 1. Now here, uh, test vectors from this Boolean expression we can write test vectors. So this is your total inputs are 4 A B C D. So here B is missing first term. Okay, if you see here in this term B is missing. So A is 1. See here A is 1, B is missing. So write don't care X, and C is write 1, D bar just 0. Okay, here second term also A is missing. So write cross don't care BC means 1 1, D bar means 0. Second one. Third one, here four terms are there. Means A bar B bar means 0 0 CD 1 1. Okay, for stuck at 0, we have three test vectors. Okay, we have three test vectors. Next, for stuck at 1, C1. Stuck at 1 means C line is stuck at 1. C line is stuck at 1. Okay, for C stuck at 0, we got three test vectors. For C stuck at 1, okay, formula is C bar into df by dc. Df by dc is this one into C bar. Okay, we will get, okay, AC, okay, AC bar D bar plus next B C bar D bar last A bar B bar C bar D. Here also three terms. Okay, here B is missing. So 1 don't care 0 0. Here 1 don't care 0 0. Second term, second term A is missing. So don't care 1 C bar D bar. So 0 0. Okay. The last term A bar B bar C bar means 0 0 0. Last D. So 1. Okay. Here also we got three test vectors. Now we can represent this text vectors, okay, in other form also. Means here we can write, okay, first this term A1, here B is missing, so we can write here 2 the, okay, okay, disappear term, here B is missing, so missing term you can write 0. Okay, C is 1, D bar is 0. Okay, you can represent like this also, 1 to 1 0. 1 to 1 0. Okay, this is one term. Next, BCD. Here A is missing. So 2 1 1. D D bar, so 0, 2 1 1 0. Next, A bar B bar C D means 0 0 1 1. Okay, this is cube method. Okay, representing here first term A C D bar, here B is missing. So the missing term you can write with digit 2. Okay, here missing term. Okay, B is missing, so we can represent it as a 2. We can represent it as a 2. Okay, this representation is called cube method or cube representation. So we will see one more example. This one is also, this is already covered. Okay, df for dxi equal to, okay, just first we will apply for 0 and we will apply for 1, and we can take exclusive or whenever stuck at 0. Okay, excitation value are xi and stuck at 1 x bar. Okay, df by dxi equal to 1. Here example. Okay, your inputs x1 x2 x3 are the three inputs. Just representing the Boolean expression here. Okay, suppose line x2, your input x2 line is stuck at 0. Now we have to generate the text vectors for the line x2 at stuck at 0 here. Okay, now first we will write the Boolean expression here. Here we will get x3 x2 bar, here x1 x2. Okay, total expression is y2 equal to x1 x2 plus x3 x2 bar. Here using the formula df by dx2, here line is x2, so just writing the x2 here with respect to your function with respect to x2 line, so writing x2 fx2 of 0 exclusive or with fx2 of 1. If we apply this one, so here we will get the formula means in the above formula initially we will apply x2 equal to 0, then x2 equal to 1. Okay, then we will get x3 exclusive or x1. Okay, first we will apply in place of x2 0, then exclusive or with, then here in place of x2 we will apply 1, then exclusive or. Okay, then we will get a exclusive or b you can write. Okay, that way we will get x3 x1 bar plus x1 x3 bar, this one. Now here stuck at 0. Okay, stuck at 0 here detecting the text vectors only at stuck at 0. So we will use x2. First, suppose stuck at 1, here we will use x2 bar. Here only stuck at 0. So x2, okay, x2 into df by dx2 equal to 1 formula. x2 into, we get this one, x2 into this term, x2 into this term, you will get, we will expand this one. Okay, we will get the here terms this one. Here we will apply here x1 bar. So 0, x2 1, x3 1. Next, in the second term, x1, x2 1 1, x3 bar. So 0. Okay, these are the text vectors to detect fault stuck at 0 in the line x2. Okay, we can represent it using the cube also. Here x1 bar. So we can write same. Here all are representing. So we can write as usual 0, 1, 1 and 1, 1, 0. Same. Suppose any missing term is there, we can represent it 2. Okay, here I have only 3 inputs, all 3 are present. Okay, we can represent like this. Now advantages and disadvantages of this Boolean difference method. Advantages. Exact method, it will find the test vectors if fault is detectable. Like path sensitization method, it does not support trial and error approach. Means there forward trace, backward trace. Okay, in the backward trace, there may be conflicts in with the other inputs, the different inputs. Here, there is no that type of, okay, uh, trial and error approach. So here, disadvantage is method is costly in terms of computation time and memory requirement. Okay, here, whenever the this inputs increases, the size also increases and complexity increases. Okay, complexity increases, but this is practically not using. Okay, there are some advanced, okay, automated test pattern generators are there. Automated test pattern generators, ATPs. Okay, nowadays these test pattern generators are using in the digital system design or VLSI design. Okay, next class we will see Kohave algorithm and D algorithm. Okay, now I will stop this meeting. No, any doubts in this class? No. 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 Okay, bye. Okay, welcome. Welcome.